All right. What is up, guys? Mr. Rushka here again. We're going to keep doing the same old. All right, just set a 45-minute timer on my phone. We'll see how far we get, okay? These are the Chapter 2 notes I've got pulled up, but let's finish those last couple problems from Unit 1 real quick, okay? So I think the last one we did was number 37, I'm pretty sure, with the cone with water in it. All right, yep, that's what we just did. Okay, we just did this problem right here. So let me go ahead and erase all of this. Get rid of all this. We can move on. All right, cool beans. Oh gosh. All right, so let's move on to number 38, okay? Number 38. Reggie invests $12,000, part at 7% annual interest, and part at 8.5% annual interest. All right. How much is invested at each rate if Reggie's total annual interest is $900? All right, good stuff here. Okay, guys. So let's think about this. He invests. So let me take a picture of this, actually. Got it. All right. So going back to the Unit 1 notes, okay? So number 38, okay? So he invests $12,000, part at 7% interest, okay? So what are they asking here? What are they asking in this problem? They're asking how much is invested at each rate. How much is invested at each rate? Okay, well, here's how we do this one, okay? So they're asking us how much is invested at each rate. So I'm going to make two variables, okay, because there's two different interest rates, and that they're asking me for how much he invested in each one, okay? So my first variable is going to be the amount invested by Reggie at 7% interest. And I'll let my y be the amount invested at 8.5% interest, okay? All right, so first off, right, he starts with $12,000 total, right? He starts with $12,000 total dollars. So the amount he puts in the 7% interest account plus the amount he puts in the 8.5% interest account has to add up to $12,000 because that's the total money he's investing, okay? Then, well, the other equation we get, okay? So he earns $900 of total interest. $900 total right here, okay? All right. He gets that, right, from the 7% of everything he invests in that 7% account plus 8.5% of everything he invests in that 8.5% account, okay? Boom. All right. So I now have two equations here and two unknowns, so I can solve for these two unknowns, okay? So I'm going to use substitution here. Hopefully you remember that from algebra. All right, I'm going to use substitution. I'll solve this first equation for x. That'll give me y equals 12,000 minus x, okay? All right, then I'll go ahead and I'll sub this in for y in the second equation. I get 0.7x plus 0.085 times 12,000 minus x equals 900. Okay, so I get that far. Let me go get my calculator. All right, got my calculator, okay? So now we have one equation here with one unknown, that is x, okay? And I can go ahead and solve, okay? So we get 0.7x plus 0.085 times 12,000. That gives me plus 1,020, okay? Then minus 0.085x equals 900. Let's combine my like terms here, okay? So 0.7 plus negative 0.085. I just made a mistake. The mistake I made is this is 0.7 should be a 0.07, okay? He did not get 70% interest, he got 7% interest. Okay, so that takes care of that mistake, okay? So 0.07 plus negative 0.085. That is negative 0.015x plus 1020 equals 900, okay? Subtract 1020 from both sides. Okay, we get negative 0.015x equals, what's that going to be? Negative 120 divided by negative 0.015 on both sides. We get x equals 8,000. There we go. So there's my x, okay? And then we can take this x, stick it right into here. We get y equals 12,000 minus 8,000, or y equals 4,000. So there's my y. Okay? And now our final answer is going to be putting this, our x and y, in the context of the problem. Okay, so x is my amount invested at 7% interest. So he invested $8,000. Don't forget that dollar symbol at 7% interest. And he invested $4,000 at 8.5% interest. There you go. Final answer right here, okay? So there you go. Pause, rewind, slow it down if you need to, okay? So I'll get rid of all this. Delete. All right, now let's do 39. Last problem of the unit. Tire of a moving bicycle has a radius 16 inches. If the tire is making 2 rotations per second, find the bicycle's speed in miles per hour. Woof! All right, this could be intimidating, okay? Let's see what's going on here, okay? So we've got a bicycle tire. I'll just draw a full bicycle, even though I'm not very good at drawing. So I guess draw its center here. All right. And then draw a little seat. All right, handlebars. Oh, math or drawing. Drawing is the hardest part of math class for me, okay? All right, so there's my bicycle. Here's the bicycle tire, okay? And the bicycle tire has a radius that's equal to 16 inches. 16 inches, okay? Let's think about this. It's making 2 rotations per second, okay? Let's think about the circumference of this tire, okay? I don't think it's too difficult to find the circumference of a circle, okay? So the circumference of a circle, C equals 2 pi r, okay? So the circumference of the bike tire is going to be 2 pi times 16, or 32 pi. 32 pi, okay? Let's think about a point on the edge of this bike tire, okay? What's happening is every second, right? This is 2 rotations per second. So every second, right, this point on the bike tire is going to move 32 pi inches around, and then another 32 pi inches around. So it's going to move 32 pi plus 32 pi equals 64 pi inches is what's going on, okay? All right. It's moving around 32 pi, or 64 pi inches per second, okay? And that's going to be what how fast the bicycle is moving forward, okay? That's how fast the bike, every 1 second, right, our bike moves far enough to make this point go 64 pi inches, okay? So we're traveling 64 pi inches per second. All right. They want my speed in miles per hour, okay? So let's do a little bit of dimensional analysis. I don't know if you remember this from chemistry, but we start out with 64 pi inches per second. Okay, we want to end with miles per hour. All right. So let's think about this. In 1 mile, there's going to be 5,280 inches. Okay, so we got to convert from miles to inches because we want miles per hour. So we need to go from inches to miles at some point. Okay, I did that my first step. Okay, I put the inches in the denominator because I need that to cancel out with this inches in the numerator. Okay, so I put 1 over 5,280. That makes sense, guys. Whenever you move from a smaller unit of measurement to a bigger one, you end up dividing. So that also makes sense from that standpoint, okay? And then we want to move from seconds to hours, right? Seconds to hours, okay? So for that, right, we're going to multiply by, right, there's 60 seconds in 1 minute. Okay, so we're going to do that. We need to go from seconds to minutes before we go from seconds to hours, okay? Seconds to minutes. Okay, and I put these seconds in the numerator because I need them to cancel with the seconds in the denominator, okay? And then my last step, there's 60 minutes in 1 hour. Okay, so this minutes, and I put the minutes in the numerator, right, to cancel with the minutes in the denominator. It makes sense that when I go from seconds to minutes and minutes to seconds that I multiply by 60, right? Because let's think about this. The bike is going to travel a whole lot farther in a minute and even more of a whole lot farther in an hour than it's going to travel in 1 second, okay? So it makes sense that I'm multiplying by 60 when I go up to like my, seconds or miles per minute or miles per hour, okay? So these all cancel, okay? And then these units I have left, miles per hour, that's going to be my final unit of measurement, okay? And so then we just do 64 pi divided by 5,280 because it's in the denominator, times 60 because it's in the numerator, times 60 again because it's also in the numerator, okay? So this is going to equal, let me get my calculator out. So we have 64 pi divided by 5,280 times 60. All right. Okay, good. So I came up with 137 miles per hour. Okay, that's really fast. Let's think about this. It's got a radius of 16 inches. Okay. Radius was 16 inches. So that circumference means it's 2 pi times 16. Yep, so it's a pretty big bike tire, and it's getting 2 rotations in per second. It is going pretty fast. I'm going to stick with this answer, okay? All right, the bike is flying. The bike's about to fall apart. All right. So that's my answer. This is the end of 1.7, guys. So we will make sure we turn in the 1.7 homework for the next class, okay? So I guess that'd be for Wednesday, tomorrow, okay? Let's go ahead and turn that in tomorrow, okay? All right, so then we've got the unit. Let's plan on I think I left my plans in my mom's room at the hospital, but my plan is we'll do a review day the day I come back, and then we'll test on Friday. I think that's our plan right now, okay? In the meantime, okay, so this is all that's going to be on the test, what I just covered. Now we're going to move on to Unit 2. This stuff is not going to be on the test, okay? So let's get started, okay? Right off the bat, they give us a list of functions, and they ask, is it a polynomial function? If not, why not? Okay, here's how this works, okay? A polynomial function that's going to be a function that only has, let me think about the best way to say this. A function that only has variables in an exponent, a multiplication, a multiplication, addition, or subtraction, okay? Can't divide by an exponent. That's a reciprocal function. That's not a polynomial function. So a polynomial is a function that only has variables in an exponent, multiplication, addition, or subtraction, okay? And furthermore, the exponents can only be positive integers, okay? So like x to the negative 2 is not a positive integer, or polynomial function, because that's the exponent is not a positive integer, okay? All right. So that's what a polynomial function is. Only has variables in an exponent, multiplication, addition, or subtraction. And it can only be a positive integer, okay? The exponents can only be a positive integer, okay? So let's look at this first one, okay? Is it a polynomial function? Well, are the exponents on my variables, are they positive integers? No, there's a negative 15 here. No, so this is a no. No, because exponent on x of negative 15, not a positive integer. Okay, next one, right? What's the exponent on x technically? Okay, so I don't know if you remember this from Algebra 2, but when you see a square root symbol with like a little number here, that means this means like a fifth root, okay? So instead of finding the square root of 27x to the fourth, this is 27x to the fourth rooted to the fifth, or find the number such that when you multiply it by itself 5 times, that equals 27x to the fourth, okay? When you see this, you can rewrite this as 27x, then in parentheses, to the 4, all right? This number inside the little radical symbol becomes the numerator, over 5, okay? The little number right here that's right outside the radical symbol, the little check mark symbol, that becomes the denominator, okay? So we can rewrite these as fractions, exponents. All right, now is this a polynomial function? No, right? That's because the exponent on x is not an integer. It's not an integer. Okay, so that's a no. C. Okay, let's look at this. My variables are only involved in multiplication. Okay. The exponent on this x is 1, okay? So actually, right, 1 is a positive integer, all right? So yes, yeah, it's a polynomial function, okay? Same for D, okay, right? We don't see any dividing by x, it's just multiplying or adding or subtracting by x, okay? And my only exponents on x are positive 1 and positive 2, which are both positive integers. So this function here, yes, it is a polynomial function, okay? Let's look at part E. We have 2x to the 5th minus 1/2 x plus 9, okay? X is only multiplied by stuff, or it's added to stuff, or it's subtracted from stuff, okay? And my only exponents on x are positive 5 and positive 1, which are both positive integers. So yes, this is a polynomial function, okay? That checks out. That checks out. Okay. All right, number 2, write the equation of the linear function given f of 2 equals 3 and f of 4 equals 11, okay? So hopefully remember from Algebra 1 and Algebra 2 how to write the equation of a line given 2 points on that line, okay? All right, so we have, right, so they give us points here, but in a very roundabout way. You might not pick up on it at first, okay? What they've done here, so like for part A, they've given us f of 2 equals 3. All right, what that means is, right, f of x is written like this, right? Or y equals f of x, okay? So what they've done is they've plugged in x equals 2 to this function. They've plugged in the value of x equals 2 to this function, and they've gotten out a corresponding y value of 3. Okay? So this means that the point 2, comma 3 is on this line, because when you plug in x equals 2, you get y equals 3 out. Okay, that's what it means for a point to be on the equation of this line, okay? Similarly over here, this gives me the point, right, this would be x, this would be y, this gives me the point 4, comma 11 on this line, okay? So now we have our 2 points. The way we do this is we use point slope form. So you use your point slope form. All right, what's point slope again? It is y minus y1 equals m times the quantity x minus x1, okay? So we don't have a point here, but we do have 2 points. We do have 2 points. We don't have the slope. We can just calculate it using these points, okay? So let's use the slope formula. So x1, y1, x2, y2. All right, so the slope m equals 11 minus 3 all over 4 minus 2, which is 8 over 2, which equals 4, okay? So my equation is going to be y minus my y1. What's y1? It's 3. That equals 4 times my x minus my x1, which is 2. Okay. All right. And then I guess we could leave it in this form technically. It just says write the equation. Or you could put it in slope-intercept form. It's not too hard. You just add 3 to both sides and distribute the 4. Okay, so you get y equals 4x minus 8 plus 3, or just y equals 4x minus 5. There we go. Final answer. Okay, there we go. All right, same thing down here, right? We're going to have 1 point is going to be negative 2, comma 0. My other point's going to be 6, comma 4, positive 4. Right? I have 2 points. I don't have a slope, so I got to calculate that real quick. Here's x1, y1, x2, y2. Okay, so the slope of this line is 4 minus 0 all over 6 minus negative 2, which equals 4 over 8, I believe. Yep. So 4 over 8. All right. Good stuff. All right, so then I can plug this all into slope-intercept form, okay? I get y minus my y1, which is 0, right? I get y1 and x1 here, 0. That equals 1/2. Sorry, this reduces to 1/2. 1/2 times x minus my x1, which is negative 2, okay? That gives me y equals 1/2 times x plus 2. All right, or y equals 1/2 x plus 1. And now I'm already in slope-intercept form here, okay? So that's my answer for this second one, okay? For part B, for B, okay? Now, moving on to quadratics. Number 3, find the vertex, axis of symmetry, and direction, okay? Here's what those terms mean, okay? So if I have a parabola, right? Let's say I have like this, okay? All right, the vertex of my parabola is going to be the point, right? So the parabola looks kind of like a horseshoe, right? It's going to be the point at the tip of the horseshoe, the very end of the horseshoe, right there. Okay, that's the vertex, okay? That's the vertex. This will be the vertex, okay? The axis of symmetry is the vertical line that passes through my vertex. All right, axis of symmetry. The parabola is symmetric, has symmetry across that line, which is what I'm guessing why it's called the axis of symmetry. And the direction refers to whether these arrows point up or down, okay? So this indicates my direction, okay? So this one would be opening up. It opens up, okay? So that's just a little background. Let's look at this one. How do we tell? All right, so here's how we do this, okay? My equation for this quadratic equation here is in what's called vertex form. Vertex form. That means it has an x plus or minus another number inside a pair of parentheses with a coefficient here. Okay, there can be a coefficient here, and then minus some number or plus some number that's outside the parentheses, okay? Hopefully we'll just be able to see this by sight. The general form for vertex, the general equation for vertex form is y equals a times x minus h squared plus k. Okay, that's the general form, okay? So the way this is working, okay, so what's the vertex here? The vertex is going to be h comma k, referring to this formula above, okay? So for this problem, right, what's my h? So my h, if I look at the number that's inside my parentheses with my x, okay, that's positive 1. My h is the opposite of that. So my h is negative 1, okay? And then my k, I look at the number that's being added or subtracted that's outside the parentheses, and that number is my k. So negative 1, negative 4, okay? So this is going to be my vertex, is the opposite of the number that's in here, comma, the number that's out here. Okay, that's my vertex. My axis of symmetry is just going to be x equals, and then my x coordinate of my vertex. Okay, it's a vertical line that passes through my vertex. Let me write this x a little better. It's driving me crazy. There we go. All right. And then what do they want? The direction. The direction. How do I find the direction? I look at my a here, or the number that's just right in front of my parentheses. Okay. If it's negative, my parabola opens down. If it's positive, if a is positive, my parabola opens up. So let me make note of that. If a is greater than 0, opens up. If a is less than 0, it opens down. Okay, so there you go. If a equals 0, right, this whole term is going to cancel, and then we're just going to have a constant function. So you actually can't have a quadratic equation whose a is equal to 0, because then you wouldn't have a quadratic anymore. Okay, so there's that, okay, guys? So this parabola is going to open down, since my number in front of my parentheses here, and when I'm in vertex form, is negative. So it's going to open down. Okay, so that's my solution, okay? Here we should be able to breeze through these, hopefully. So my vertex is, okay, the opposite of the number that's in parentheses, okay? So this is a minus 3, so my vertex is going to be positive 3. And then there's technically a plus 0 here, so my vertex is going to be 3, 0. Similarly, my AOS, my axis of symmetry, is going to be x equals 3 because it's just x equals, and then the x coordinate for my vertex, and then the number in front of my parentheses here is positive, 1/2 is positive, so it's going to open up. All right, opens up. All right, moving on. Okay, so we have a positive, a +3 here inside my parentheses. So the x coordinate of my vertex is going to be the opposite of +3, which is -3, comma, and then just this number outside my parentheses, 10. The number in front of my parentheses right here is positive, so this parabola opens up. And then my axis of symmetry, right, it's just going to be x equals, and then the x coordinate of my vertex, or -3, okay? So there's that, okay? Got that going for us. Okay, good stuff. Number 4, find the vertex, axis of symmetry, and direction of the following by rewriting them in vertex form. Okay, so now, right, they want me to basically do the same thing I did in this last problem, but now they give me my quadratic equation. It's in standard form, which is standard form is y equals ax squared plus bx plus c. Okay, it's in standard form now. So what I have to do is, like, in my additional step here, is I first have to go from standard form to vertex form. Okay, so go from standard form to vertex form. Okay, so let's do that here. How do I do that? Well, here I do that by completing the square. So I'm going to complete the square. I get f of x equals, okay? I'm going to factor out my -2 from these first two terms. It's going to be -2 times x squared minus 2x, okay? I'm going to leave a little space, -3, okay? So I just factored out this -2 from my first two terms. I factored out the lead coefficient for my first two terms, okay? That's the first step. Factor out the lead coefficient from the first two terms, okay? Second step, I look at this number that's right next to x here, the number that's right next to x. I divide it by 2, so -2 divided by 2 is -1, and then I square it. So -1, so -2 divided by 2 is -1, and -1 squared is +1. And I'm gonna add +1 here inside my parentheses. Okay. What I just did is I didn't just add +1 to this equation. I added right when I distribute out this -2. I'm going to see that I subtracted 2 from this equation. So I've got to add 2 to make up for that, okay? I can't just subtract 2 over here on this right side of my function without changing the equation in an illegal way. I have to do my -2 and a +2, which means I'm adding 0, which is allowed, okay? So to make sure I don't add or subtract anything extra, I got to make sure I compensate outside the parentheses for whatever I added to this equation inside the parentheses, okay? I put a +1 here inside my parentheses, which translates to a -2 times +1, or just a -2 outside my parentheses. So I've got to balance that out with this +2 by adding this +2 here, okay? So then this gets me f of x equals -2, and then this 3 terms inside these parentheses actually constitute what's called a perfect square trinomial, which means I can rewrite this trinomial, this set of 3 terms, as these 2 terms x minus 1 quantity squared. Okay, notice that this is just x minus, and then it's going to be 1/2 of this coefficient of x, the coefficient of my x term here. So x minus 1/2 of -2, or just x minus 1. All right, and that's all going to be quantity squared. If we FOIL this back out, we can check, okay? Then negative 3 plus 2 is going to be negative 1 or minus 1, okay? We can check to make sure we did that right. We can do f of x equals, let's FOIL this x minus 1, okay? Negative 2 times x minus 1 times x minus 1 minus 1. We get, let's FOIL first, x squared outer, negative x inner, negative x last, plus 1 minus 1. All right, I can't forget this negative 2 that should be here. All right, or negative 2 times x squared minus 2x plus 1 minus 1, or negative 2x squared plus 4x minus 2 minus 1, negative 2x squared plus 4x minus 3, which is my original function here, okay? So you can always check to see if you completed the square right by expanding everything back out, okay? So now I have my equation in vertex form. All right, so my vertex, right, it's going to be the opposite of this number inside my parentheses. So the number inside my parentheses is negative 1. So the opposite of that is positive 1. So it's going to be positive 1, comma, and then just the number outside the parentheses that's added or subtracted. So positive 1, comma, negative 1. Axis of symmetry is going to be x equals, and then the y-coordinate of my vertex, or sorry, not the y-coordinate, the x-coordinate of my vertex right here, which is 1. All right, and then my number that's right in front of my parentheses multiplying them is negative 2, so it's going to open down. Opens down. All right, so those are my solutions here. Good stuff, okay? Let's look at this one, okay? So I got to factor that lead coefficient out of the first two terms. That is 1/2. It's 1/2, guys. Kind of a pain in the butt, but I got to do this. Okay, so it's going to be f of x equals 1/2 times x squared. All right. How do I factor out 1/2 from 6? Okay, well, I got to put a number here such that when I multiply it by 1/2 to expand back out, I get 6. Or negative 6, I should say. What number is that? It's negative 12. And then I have my x. Okay, leave some space for that third number I'm going to add in. And then I have my plus 1 that's just been hanging out. Okay, so I have that plus 1 there. Second step, I look at the number next to x. That's right next to just my regular old x term. That's negative 12. I divide it by 2. That gives me, I divide it by 2. That gives me negative 6, and I square it, so that gives me positive 36, okay? All right, so in doing that, right, and putting a 36 here, I really added 1/2 times 36, or I really just added 18 to this equation. So to balance that out, I got to subtract 18 as well, okay? Then I can write this as x minus 6 squared. And then my plus 1 minus 18 gives me minus 17. So f of x equals all that, okay? So it opens up, right, because that 1/2 there in front of my parentheses is positive. And then right opposite of negative 6 is positive 6. And then I have my number outside my parentheses is just negative 17, so that's the vertex. And the axis of symmetry is just the x component of my vertex, okay? There we go. All right, this one right here. All right, so I'm going to go ahead. So I'm going to factor out my lead coefficient from my first two terms, my only two terms here. That gives me f of x equals 3 times x squared plus 4x. Okay, leave a little space here, and then I've technically got a plus 0 here, I guess. Okay, take the term next to my x, or the number right next to my x and my x term. divide it by 2. So I have 4 divided by 2 is 2. Square that. 2 squared is 4. So this is going to be add 4. Right? And adding 4 inside my parentheses, I really added 3 times 4, or 12. So I've got to add a minus 12 to balance that out, okay? So then I get 3 times, let me rewrite this as x plus 2 quantity squared, and then that 0 minus 12 is just minus 12. All right, so that's what f of x equals, okay? Good stuff. Okay, so then it opens up because that 3, this 3 in front of my parentheses is positive. Okay, and then my number inside my parentheses next to x plus 2, the opposite of that is going to be the x-coordinate of my vertex, and the y-coordinate is just going to be this number that's outside my parentheses right after them. So negative 2, comma negative 12 vertex, and then the axis of symmetry is just x equals, and then that x-coordinate of my vertex, which is negative 2, okay? So there's my solution, okay? All right, so now challenge is to find the vertex, axis of symmetry, and direction of the following quadratics by using the axis of symmetry formula. So instead of completing the square and rewriting these in vertex form, they want us to find everything using a special formula. Special formula. Here's how this works, okay? The x-coordinate of my vertex is equal to the opposite of b all over 2a. Okay, what's a and what's b? Okay, recall, so this equation's in standard form, or the form y equals ax squared plus bx plus c. So, right, we label this number in front of my x squared as a. I label the number in front of my x as b. And I label my constant term, or the term with no variables, as c. Okay? So then the x-coordinate, my vertex, or my h, put that in parentheses, is equal to the opposite of b. What's that here? It's 16. So the opposite of b, negative 16, over 2 times my a, which is negative 4. It's going to be negative 16 over negative 8, which equals 2. Equals 2, okay? Right, so that's my vertex is 2, comma, and then how do I know what the y-coordinate is? Well, I can just take the x-coordinate of my vertex, plug it into the equation, and then just see what it pops out for y, and that'll be the y-coordinate of my vertex, okay? Because that x-coordinate is still a point on this equation. All right, I can plug in that x value and get out a y for it, okay? So let me do that here real quick, okay? So I get y equals negative 4 times 2 squared plus 16 times 2 plus 3, which equals negative 16 plus 32 plus 3, which equals negative 16 plus 35. What's negative 16 plus 35? Right, it's 19. All right. So the x-coordinate, or the y-coordinate of my vertex is 19. So that's my vertex. Axis of symmetry follows right from that. Right, x equals the x-coordinate of my vertex, which is 2. That's the axis of symmetry. And then how do I know whether it opens up or opens down when it's in standard form? Well, what you do is, to determine that, you look at the number, the coefficient of my x squared term, okay? If it's negative, like it is here, my parabola is going to open down. And if it's positive, my parabola is going to open up, okay? So you look at the number in front of my x squared, okay? If it's 0, I'm not going to have an x squared term, and I'm going to have a line, which means I'm not even going to have a parabola, so I don't need to worry about that. So here, my lead coefficient is negative, so I'm going to say it opens down. This parabola opens down, okay? So there's that. Oh, there goes the timer. We'll pick up on this, okay? So then 1.7 homework for next class, guys, okay? And then test Friday, okay? Keep memorizing your BFFs. You take care, guys. Bye.